Today we have Dr. Antunano. He was born in Mexico City and is a graduate of the National Autonomous University of Mexico School of Medicine. He completed the residency program in aerospace medicine at Wright State University in Dayton, Ohio. He was a postdoctoral research associate with the U.S. National Research Council of the National Academy of Sciences at the USAF School of Aerospace Medicine in San Antonio, Texas. He is the director of the FAA Civil Aerospace Medical Institute, or CAMI, in Oklahoma City. He is credited with 991 professional presentations and invited lectures at national and international conferences in aerospace medicine in 41 countries. He is past president of the International Academy of Aviation and Space Medicine, the U.S. Aerospace Medical Association. He has received 87 awards and recognitions for his academic, administrative, and research achievements. He has experience as private pilot, parachutist, and scuba diver.
Thank you very much. Appreciate the introduction. But I will tell you, the most important thing is I do not have a job. I have a hobby with a salary. So that will be one of my recommendations to you. Find your passion. Find what you want to do. And if you pursue a job related to that, it will not be a job. It will be something that you will be enjoying every single day for the rest of your life. So don't do things just because of somebody else pressuring you to go in a particular area. Find your own passion and then follow it. Now, with that in mind, how many of you just raise your hand if you want to pursue a career related to science? Just raise your hand. Okay. What about some related to arts? Okay, we have a few. Who wants to pursue politics? Anybody? Two. Wow. Now, within the area of science, how many of you are interested in the medical field? Excellent, because I will tell you, that's right now one of my challenges. For the Civil Aerospace Medical Institute, we're looking for physicians who have aviation and space medicine training, and it's very difficult to find them. There are only 2 residency programs in aerospace medicine, and we're not producing enough doctors. We have a shortage today of pilots, a shortage of air traffic controllers, a shortage of engineers. How many of you are interested in engineering? Excellent, because that you will find jobs all over the place. And part of the problem that we have is that we are actually competing with the Department of Defense, with NASA, with private companies for the same engineers that we're looking for. So anything in connection with science that you can do now, that's perfect. But also I mentioned arts, because arts, that's another area where yes, we have a lot of a market right there, but now the connection of art with science, that's another thing that you should think about. For example, there are people working at NASA, people working at the FAA, that they have degrees in arts. But then, for example, if it is illustration, if it is issues about using arts to actually promote aerospace activities, that's huge. But also in connection with new technologies related to medical technologies, but then from an artist point of view, is how can you create some designs that are pleasing to the eye, that are practical, that you can use, that people will actually want to buy. All of those considerations come from a different area that is not science. So all of this integration of different fields, that's what we have at the Civil Aerospace Medical Institute. That is a piece of aviation history. That was one of 3 airplanes ever produced. It's called a Learjet jet. But that's also to show you that sometimes technology is too ahead of its time and it's not the right time to actually introduce it. This airplane was developed in 1978, carbon fiber. Back then, it was going to be 10 times as expensive to sell it as other comparable aircraft. So it was too ahead of its time. It was not the right time to do it. And that's what's happening with many different areas of technology that I'm going to be sharing with you. So we have that airplane in front of the building, and that's where we are. Our institute is the only one of its kind in the world based on what we do in the United States. We have 5 program areas. We have medical certification. We process the medical certificates for 520,000 civilian pilots in the United States. We have another division that is the education division, where we train the doctors who do the physical exams of the pilots in the US and in 92 countries around the world, and physiology training, human factors training that I will cover in a little bit. Then we have two research divisions, one in aerospace medicine research, one in aerospace human factors research. By the way, how many of you are interested in doing research, scientific research? That's another huge area. We are struggling between different government agencies to find enough scientists interested in pursuing research. So once again, if it is research related to engineering, if it is research related to medicine, research related to biology, pharmacology, all of those different areas are good. How many of you are interested in, for example, forensics? One, two, a couple of them. So, but what we do at the Institute, that's another program area where we actually receive every day remains of pilots who die in aviation accidents. So last year we had about 300 pilots who die in civil aviation accidents, and we at the Institute, we look for hundreds of medications, illegal drugs, alcohol, and we developed the new methodologies to identify what people have been doing before they die. So we are doing also genetic research to try to identify, for example, based on remains. Can you tell today, let's say that you die right now, and then your body decomposes. Can I say if you were tired before you die? Is there anything that I can measure to tell you that you were tired before you died? The only thing that I'm getting from you is your remains, pieces of you. Based on pieces of you, can I say if you were tired before you died? It's not possible today. Well, we are doing gene expression research that we already identify biomarkers to see if before the person dies, that person had fatigue. We are going to revolutionize science, forensic science, with that particular research. You have seen in the movies, on TV, that you find, or people in the, well, detective programs, they find the skull of a person, and based on the skull of a person, they reconstruct the soft tissues to see how the person looked. That was invented in the Institute here in Oklahoma City. Passenger oxygen masks were invented here. Floor lights for aircraft were invented here. Bunch of other things that were developed here, and people don't realize that took place here in Oklahoma. So from here now, let me jump because I will go faster. That's part of the facility that we are going to restart a program that we used to have where we could offer to some of you who were interested the possibility of rotating at the Institute and having an internship at the Institute. We used to do that before COVID-19. We are having discussions to restart that program. And let me tell you, if you have the opportunity, you will have a blast doing that, because almost the stuff that we have there is exciting, as you're going to see, okay? And let me put it this way, we have tons of toys for adults that you will be able to play with as well. Flight simulators, we have crash dummies, we have all kinds of things that... So, but anyway, now let me jump from this one. These are the types of specialties or people that we're looking for as far as careers with us. We have physicians, physician assistants, anything typical in the medical field, but at the same time, as you can see there, physiologists, specialists in training programs, because we also provide training programs. So we're looking for people who know how to design training programs. Of course, computer simulation specialists, mathematicians, radiobiologists, even librarians. So as you can see, we are looking for almost everything that we can think about. In fact, we also have an attorney, and that's unusual, but that attorney happens to be also a physician at the same time. So that's a good combination. So let me jump to this, because really what we at the Institute is the human-machine environment interactions. And that has been the definition over the years of human factors. What happens to a human, could be a pilot, could be you as passengers in an aircraft. When you are inside an aircraft, inside that aircraft you're interacting with a machine, and at the same time that machine is in the air or is in space. So what is the impact of the stresses of flight or the stresses of a space flight in the human that is on board the vehicle? So at some point I may come and give you another lecture that is, now with all of these technologies, any of you is wearing a medical wearable, like a Fitbit or anything that is recording your heart rate? Just raise your hand if you are wearing. Your cell phone, aren't you recording heart rate in your cell phone or doing some of the things with your cell phone? Well, all of that technology is evolving, and that's another area that I suggest to some of you, particularly if you're interested in engineering. Go to biomedical engineering to develop the next generation of biomedical sensors. There is a huge, huge market for that. Now, the future, here is the reality. The future is now, and we should not resist it. We should embrace it. Technology is evolving now, not at a linear pace. It's an exponential case. It's logarithmic, okay? As a result of that, in many cases, technology is happening faster than how fast we can prove that the technology is safe. So that's a huge challenge for all of us. And in our case, in particular, because of aerospace activity. So let me give you here a panoramic view of what we are dealing with within the Institute. We are dealing with different modes of transportation, and I will cover some of them today. But we are dealing with flying cars and flying motorcycles that they want to certify to be used in the United States. Of course, commercial space flight crews and participants, you know about SpaceX, you know about Blue Origin, about Virgin Galactic. We actually regulate all of those commercial space operations. And I have been involved with the development of the medical requirements for space passengers and the crew members. We are dealing also with personal flying machines. That's one of my areas of interest. We're talking about people with backpacks with microturbines. In fact, we started having problems already in the United States. In Los Angeles, about 3 months ago, there was a captain of a Boeing 747 that called traffic and said, I have this guy with a backpack with microturbines crossing in front of me when I'm trying to land the aircraft. So they are developing all kinds of these vehicles. I will show you some examples of those. I love one of those. I would like to buy one of those things so bad, but they are not legal yet in the United States. We're going in the direction of maybe changing cargo operations and passenger aircraft, eliminate the co-pilot and go with a single pilot. And there the question is not if the technology is ready. The question is, how many of you, if you board the aircraft to fly somewhere and you look to the left when the cockpit is open, how many of you, if you only see one seat in the cockpit, would not want to fly? I know, some of you will say, wait a minute, where is the other guy? Well, there is no other seat. So we're in that direction of eliminating the co-pilot and eventually no pilots on board, completely automated. Another area is drones or unmanned aerial systems. I will talk a little bit more about that one. And the other one is advanced air mobility, air taxi operations. And I will show you several examples. We're under pressure to try to certify air taxi vehicles to take 2, 4, 6, 8 passengers with no pilot on board. Just the vehicle you get in, it takes you somewhere, and that's it. So are the systems, automation systems. And then, of course, in addition to that, artificial intelligence and machine learning systems ready to make it safe, even if you don't have a pilot on board. Now, keep in mind this, Blue Origin and SpaceX, the only people that are on board those vehicles, those capsules, are passengers. There is no pilot on board. There are fully automated flights going to the International Space Station and going in space. There is no pilot, and there is no remote pilot either. So when you saw William Shatner, Captain Kirk flying in the Blue Origin, no crew members, only passengers on board. So that's something that is changing as a result of technology. So now let me show you a couple of things. This is another area with new types of aircraft. This Boeing 787 that looks like any conventional aircraft is not the same. When you are flying in any aircraft, let's say that you fly to Europe or you fly in a long distance, inside the aircraft, we have to change the pressure to keep you alive, okay? So inside the aircraft, in all of the other aircraft in the fleet is the equivalent of being at 8,000 feet. Like if you were at the top of a mountain that is 8,000 feet, that's the maximum cabin pressure inside those aircraft. Which means that you may have some medical issues that even at 8,000 feet you have problems because it's too high for you. With the newer aircraft, you can maintain a lower cabin pressure, 5,000 feet, which means from a medical point of view, and think about your relatives who are older age brackets, your grandparents or some other friends who are getting older, the best airplane to fly if you have a medical problem is the Boeing 787 and the Airbus 350. Because the airplane flying at a higher altitude, inside the aircraft is a lower altitude. Therefore, you are protected from changes in flight. Okay? And that can be something as simple as anemia. You know what anemia is all about, that you don't have enough red cells to oxygenate your body. Well, with this airplane, that's going to be protected. Okay? So this is the other aircraft. By the way, in this airplane, another change in technology. You don't use shades to block the light coming through the window anymore. It's a switch. You turn it on and off. The window is made of photochromic material, which means with application of electricity, you turn it from completely opaque to completely transparent. And there are companies that are starting to develop these windows for houses and buildings, where you don't have to have curtains at home. All you do is push the switch, and I will turn the windows opaque, so you don't have to have the light going through the window. So that technology is evolving fast. Now, you have seen also more and more color, or very pure colors inside the cabin. Why? Based on NASA research, it was determined that if you can control the color of the environment, you can control the motions and the reactions of people. So as a result of that, if you want your passengers to go to sleep, you use certain color. If you want them to be awake, you change the color. If you want them to be calm and not become disruptive in flight, you use the right color. So this is being used, for example, on board the International Space Station and by the space controllers that are in communication with the International Space Station. So you will see more and more of the use of color lights to control the behavior of people. Now, I mentioned to you about the reduced crew or single pilot commercial transport operations. There is research going on around the world. Of course, here you need, once again, engineers, human factor specialists, you need designers, you need, in this case, even for the design of the equipment itself, well, the better you have an artistic approach is how nice it's going to look, and that's important also. The colors that you use, all of that is very important. But it is nothing new because we have been flying private pilots or small aircraft for years with just one pilot. So as far as the technology is concerned, we could have started flying passenger aircraft with no pilots touching anything about 10 years ago. Because the automated systems on board the aircraft and then the navigation systems can communicate with each other. The only thing that we couldn't do today is once you land successfully in an automated fashion, now that the airplane has to taxi all the way to the terminal, that is not automated. But everything else, from takeoff to landing, it can be done automatically. Why we're not doing it? Because we're not comfortable enough to tell the population that, sorry, your pilot is not flying the aircraft, it is the computers on board the aircraft. So there is an issue about public acceptance of this that we have to deal with at the same time. Also, business aviation operations, the small jets that are used by companies, we started doing that about 11 years ago with just one pilot, so it's nothing new. But let me share with you, even the military in the United States, in October of last year, the US Air Force, and at Tink Air Force Base, they have these tankers that you have this big aircraft that in flight is refueling other aircraft. So for that, you have the pilot, and then you have that tail boom right there, that's how you resupply gas to another aircraft. Well, you have a person who is controlling how that thing moves in flight. So at this point, you have about 4 to 5 crew members in a normal operation. They did a test in October of last year where they only had one pilot and we had one tail boomer. So they demonstrated that yes, they could do the operation only with 2 people on board that aircraft. Now, that's in the military side. Could we do that in the civilian sector? So the idea is that yes, in fact, there are studies going on right now in Europe to see under what conditions we can allow that to happen. Now, here is another issue. What will be the role of artificial intelligence and machine learning? How many of you have tried ChatGPT? What is that? You haven't tried it? Oh, I see. Okay, no, you haven't used ChatGPT, I'm sorry. Now, personally, in the medical side, ChatGPT is not there yet because you can ask about a medical case and it will give you some answers that you say, what? I'm not going to do that with a patient, I'm sorry. So, but there are other areas where artificial intelligence, for example, for medical imaging, not to replace, but to help radiologists, is making a huge difference. So there are about 540 applications of artificial intelligence in medicine, and 75% of them are for medical imaging and also for dermatology. that if you go to a dermatologist, what is the dermatologist going to see? Well, see what kind of lesion do you have in your skin. Couldn't you identify all of the different types of medical issues with the skin, program those into the computer, and have artificial intelligence tell you most likely that's a mole or most likely that's cancer? So, but instead of making a decision for the doctor, essentially it helps the doctor come up with the right testing and the right decision on what the problem is all about. So here is the continuum that we have for reduced crew operations, like going from 2 pilots to 1 pilot. In fact, let me jump this one. I don't want to spend time on that one. These are the challenges that we have with that. Each window, we could spend easily 30 minutes talking about each one, but I will not. But just go to the flight, the bottom one that says flight crew roles and responsibilities. If you go to that one, now we have automation, artificial intelligence. What is now the role of the pilot? Is it to control the aircraft? Is it to monitor what the computers are doing? How is the pilot going to know if the computer fails? So there are many issues there that we need to take care of up front. Then, of course, pilot workload and performance. Well, you can say that, well, that's going to reduce the workload. Maybe, maybe not. Maybe it increases the workload trying to identify what the computers are doing. So all of these are different factors that we need to pay attention to. And I will tell you, those of you who express interest in becoming engineers, in fact, I didn't now ask, how many of you would like to be pilots? Anybody? Not one? Come on, one. Okay, we need to talk later on. You know, that's, come on. That's another area that right now we are suffering. In fact, OU and OSU, they have increased the number of students that they're accepting to go into aviation careers to become pilots, because we're not producing enough. That's why you hear that some of the delays and cancellations are because of weather. Some of them are because we don't have enough pilots. Many pilots retired during COVID-19, and we have not replenished the total number of pilots that we used to have before. So we need more pilots. So that's another very good career that you can follow. Now here, just pay attention to the top right, where you see the captain there, that we say now, let's say that we have this single pilot now. We don't have a co-pilot. So what will be the role of the airplane? To monitor what's the status of the pilot. I would like for that pilot to be monitored with biomedical sensors, that if the pilot becomes incapacitated, the airplane, through the computers, can detect that the pilot cannot fly the aircraft anymore and actually take over control of the aircraft from the pilot. Now, one question for you, do we have a sensor that can tell me if a person is dead? A heart monitor depends upon the definition of death. It changes from country to country, in the United States from state to state. In some states it says, well, it's the absence of heart activity. We know of cases where there was no heart recorded, and minutes later the person recovered. So what is an actual sensor that tells me you are really, really dead? Doesn't exist today. It doesn't exist. So whoever comes up with a design of a death sensor or a sensor for death is going to make a lot of money, because we can use it in many different types of environments to determine whether the person is still alive. Now, wouldn't you want to know, for example, on final approach to landing, you're almost going to touch the runway, and the pilot dies, and is the only pilot. Don't you want the computer in the airplane to say, well, the pilot is dead, so I have to land the aircraft? I would want that to happen. But right now the sensors are not there, okay? So we need to do more research. But that's nothing new. In the auto industry, Ford Motor Company, Toyota, they're actually working on doing that exactly. So in fact, I saw a prototype in Silicon Valley in California that they can actually monitor the driver for asthma attacks, for diabetes, for allergic reactions, where in the demonstration is the car is monitoring a diabetic driver. And if the person, their blood glucose is going down, what's likely to happen to that person? To become unconscious. So the car tells the driver, you better eat something because your blood glucose is getting low and you could lose consciousness. The driver doesn't do it. What's the next message? I'm stopping the car and calling 911 because you're going to become unconscious. So that type of technology, what's more difficult, to automate a car or to automate an aircraft? More unexpected things can happen when you're driving a car. So from a technology point of view, it's a lot easier to implement this in aviation because once you're in the air, no big deal in monitoring what's going on. And as I mentioned, Toyota is working on this as well, and they are using a new generation of radar technology where they can actually develop sensors, and those sensors, based on radar technology, can do all of these different things. It's amazing what is being done. It's not electrical activity, it's radar applied to medical purposes. We had here in Oklahoma City about a year and a half ago a forum on the application of radar technology for other uses, including medical. It's amazing what's going on in that environment. Now, this one I'm showing it to you because since January of 2021, we started certifying pilots who are diabetics, who need insulin, but who already have an insulin pump, as long as they have continuous glucose monitoring patches. With that one, you can keep it for up to a month, and you can set how frequent you want to get the reading for blood glucose, which could be as often as every minute. Therefore, we have more control over that person fluctuation of blood glucose. So we have about 250 pilots, including some airline pilots with this system, and it's working very well. Now, other areas of technology, and I will not talk about, well, just a quick thing on this one. We have a big problem around the world that most airports are located in areas that used to be isolated from the cities. Now they are part of the metropolitan areas, surrounded by populated communities. What's the problem with that? Noise. So now many people are suing governments because they are being exposed to noise living close to an airport. So what can we do? Change operations, but also certain types of aircraft should not fly into those airports because they are too noisy. So one other thing is develop new generations of aircraft like this. This design would not only decrease the production of noise, but increase cargo capacity, more passengers. But a simple question to you, if you have a design like this one, where would you put the windows? Where you could have up to 2,000 passengers inside this aircraft. Where would you put the exits? So there are human factors considerations as far as cabin safety when you go into designs like this one, okay? Occupant-centered aircraft designs. I mentioned to you that airplane had the Boeing 787 has the photochromic windows. Well, there are a couple of manufacturers that they would like to convert the upper structure of an aircraft into a transparent structure. So how many of you are afraid of flying? Don't have to raise your hand. How many of you may be afraid of heights? So for those people, probably it's not a good idea to have a transparent aircraft, okay? But for many of us, the rest of us, yes, I want one of those things. But then another area of technology, look at the bottom right. Why don't we extract heat from the people to operate some aircraft systems instead of using fuel? That can be done today. Now, if they do that to me, they better discount the cost of the ticket because they're extracting my heat from my body. Okay, so that's the thing. But can it be done from a technological point of view? Yes, it can. It's radiation heat that you can extract directly, not even in touch with the human body. So there are many developments in that particular area as well. Now, here is the first application of something, not having real windows in an aircraft. So Dubai Emirates Airlines is the first one that using a fiber optic system, do you see those big windows? Are not real windows. Are computer screens that are projecting information collected from outside the aircraft. So in theory, we should have airplanes with no windows. Anybody thinks why airplanes with no windows? Every window that you have in an aircraft is already affecting the structure of the fuselage. That could make it more likely to have a decompression in flight. So if you have no windows, it's safer. How can we do it? With this type of technology. Replacing windows with virtual windows. Very light jets, we have the Viper on the top right. is a home-built kit that you can assemble. It costs, well, I will not tell you how much it costs, but there are about 30 of them flying where you assemble the prefabricated parts, and that airplane is for general aviation use. So there are several others, and there are other airplanes that are production, like the ones I'm showing you there. This is one of the latest ones being developed here in the United States that is being targeted for commercial, for business aviation. But once again, flying at a higher altitude, less noise, more fuel efficiency, all of those benefits. Now, what about hybrid aircraft? We have the B-22 Osprey in the military, takes off like a helicopter, lowers the engines, and then flies like an airplane. Something is being developed in the civil aviation sector is the Augusta 609 from Italy. They want us, the FAA, to certify that particular type of vehicle. Here's another one that is being pushed or being offered to the military. Now, unique aircraft types. Here we go into flying cars and flying motorcycles. This one, I know two of the engineers, they actually got a PhD in aerospace engineering at MIT. So they created this company to have a flying car. Over the years, up until about 2.5 years ago, a Chinese company bought this, but it uses normal car fuel. It's not something fancy, so it is cheaper to operate. We, the FAA, we gave them an airworthiness. That means that they can fly. It's a certificate in 2021. But now think about this. That's a cockpit inside. So I can drive it as a car or fly it as an aircraft. So how do I make sure that the control systems make the transition from the flying mode to the car mode and vice versa? So that's part of the human factors design on that. Since you don't have any pilots, I'm a pilot as well. When you are in a general aviation aircraft, you have 2 pedals on the floor for your feet. There is no accelerator and there is no clutch, or there are no brakes. Those are to turn the vertical stabilizer on the tail that gives you the direction of the aircraft. That's how you control going straight. But if it is a car, you are not using that. You are using the steering wheel. So how do you make sure that when you know that you're going to take off, the controls switch the mode of operation? And this is another one that was already certified by the Civil Aviation Authority of the Slovak Republic, but they want to get certification in the United States. We had a presentation from this company last year. It is a sports car, 2-seater. It is expensive, but I will tell you, there are many people who can afford something like this. So at this point in the US, flying cars and flying motorcycles, we are not going to allow them to take off from the road. Because the temptation is that if there is too much traffic, well, I'll just go flying and that's it. No, if there is too much traffic, you don't have space to take off or to land. So they still have to go to an open area where they actually take off and land. So it is a little bit different. Another type of flying car, this one is in production. You can buy it today from the UK. That's a 2-seater. This one is a 4-seater, including one model that is a retro look for the baby boomer generation, my generation. Then you have a flying trike. So yes, it's like one of those trike motorcycles that you can buy, but modification with collapsible or with foldable wings to actually be able to go flying. Here you have this one. This one is being developed in Europe. I love this thing. Maximum altitude, 100 feet. That's it. So if you want to ride it as a motorcycle, it has 4 wheels, 2 in the front, 2 in the back. But the wheel hub is a micro turbine. So if you want to go flying, you just spread the tires, start the turbines, and then you start going up and then start flying. I love one of those things. Oh, I want to have one. So, and you see the engine right there for the motorcycle mode is an 8-cylinder engine from a car. That's all. So I'm just showing you a few because there are so many of these different designs that are being developed. Electric aircraft, there are tons of them as well, including this latest one that now there is a racer that can fly at 300 miles per hour, and it is an electric airplane. Now, what's the issue with all of these new airplanes, electric? We do not have enough experience with electric propulsion and electric battery storage. So that's the safety challenge for us. How do we make sure that those systems are safe? that they will not have. Have you experienced that your cell phone gets extremely hot? That's part of what is called the runaway effect. I will tell you, we have done some testing where you actually go beyond that and the batteries explode. Lithium-ion batteries, okay? So we don't want that to happen in an aircraft, okay? You don't want that to happen when you're using the cell phone either, but that's a different issue. It will not happen because of how it is designed, but still will get very hot. Europe, they are developing the first commercial aircraft for regional operations, electric. Now, I love this one, next generation later than air. We're talking about the blimps. And you have seen the Goodyear blimp, 5 minutes, okay? That blimp is, you have to keep it in a hangar. So it has ropes, and you can see the ropes on the right one, on top right. So people on the ground have to grab the ropes, take the vehicle out, then goes flying, grab the ropes back, and put it in the hangar. That technology is changing fast with this. This is a blimp with a hovercraft landing system that is completely autonomous. It can taxi on the ground. You don't need anybody to grab ropes or anything. It was being developed for the military. Another company continues the development for the civilian market. So here I'm going to show you just a little bit about that. Okay? And I will finish with personal flying machines. And this is my area of personal interest because there are so many things going on here, so many developments that I'm going to show you just a few ones. This is one that was actually demonstrated in Dubai. And one of the princes in Dubai wanted to buy on the spot 20 of them. They have not been certified yet, okay? So, but he wanted those. Then here you can see the vehicle, how maneuverable it is, how controllable. If you can do it inside the hangar, you can do it outdoors. And here, this is one of my favorite ones. It has 6 microturbines. You can buy that today. In the United States, we have not allowed that officially to fly. It comes from Europe. They cross already the English Channel with this thing. And you can have a maximum speed close to 100 miles per hour with this thing. Then if you're not that coordinated, just controlling with your feet and all of that, then you just add those sticks. If you want to go forward, push it. You want to go back, pull them to the right, to the left. So you can make it a lot easier to fly. And I finish with this one, which is a company developing the JB9 with jet engines. That was the first generation. So 10-minute flight. They have improved that with the JB10, 7% more power, but also longer flight. And this is the latest one, the JB11. Up to 150 miles per hour with this thing with 6 microturbines. I want one of those so bad, but it's not certified by the FAA yet. But the lighter you are, the longer you can stay in the air. So if you're skinny like me, probably you can stay for up to about 40 minutes in flight. Imagine how much fun one of these things, okay? And you have seen this in the Discovery Channel, the Learning Channel, the Daedalus. So the Swedish Coast Guard is using it for patrol operations, but of course they want to commercialize it for civilian use. And let's stop right there. We'll talk about drones and advanced air mobility at another occasion. But this is just to give you a flavor of everything that is going on. I didn't talk about drones. I didn't talk about advanced air mobility. I didn't talk about commercial space vehicles. I didn't talk about some other modes of personal flying machines, not like the ones that I showed you with microturbines. But what is the bottom line here? The challenges for us are great. How do we incorporate all of these different ways of flying and share the airspace so that it's still safe for everybody? That's part of the challenge. What is the role, for example, now of air traffic controllers? Is the role of air traffic controllers going to change that when you have vehicles that are not even remotely controlled, they are fully automated, what will be the role of air traffic controllers now? When at the same time that you have a fully automated vehicle, you have other piloted vehicles. Then for those personal flying machines, are they pilots? By legal definition, they are not. Are those aircraft? They are not. So what will be the standards, certification standards that we develop to allow them to fly with these things? And let me tell you, the technology is advancing so fast that we cannot just say, well, we are not going to certify. If we don't do it, other countries will, and we are going to lose the market. So we cannot afford to do that. We have to facilitate the introduction of all of these different vehicles so that they become commercially successful. So here now, a bunch of challenges for you, and from different perspectives to deal with these things. One thing for those who are artists, did you know that the spacesuit that is being used by SpaceX, that now the white suit that you have seen, that was actually designed by an artist to make it look cool, not only to be functional, but to make it look nice. And definitely, that suit has attracted so much attention of the public that now they're interested in space because those suits are cool. Let's forget about everything else. It's just the coolness of what's going on. So everybody has a role here. So any questions? We have a few minutes. I have, let's see, 1:28. Okay. Oh, yeah, I still have about 5 minutes for questions. Aerospace medicine. What's the definition of aerospace medicine? Everybody asks that question, including other physicians. They don't know what it is. We are specialized, and it's a 3-year specialty program. There are only 2 universities in the United States where you can become a specialist in aerospace medicine. Right, it's University of Texas Medical Branch in Galveston, and then we have another program that is combined with the military. So essentially, we become experts on what happens when you expose people to flight in aviation, flight in space, or other occupations that have to do with aviation, where, for example, something as simple as this, and most physicians don't know. If you have a pilot and that pilot gets a cold, that pilot should not fly. Why? Because then you cannot compensate the change in air pressure. When you fly, what happens with your ears? They pop. But they pop because there is a small pipe between the middle of your ear and the back of your nose that allows air to go out and air to go back in to compensate the pressure behind the eardrum. If you have a cold, that's swollen, and that can become incapacitating. I experienced that in flight. I wanted to perforate my own eardrums because the pain, I don't know if it is like having a baby, probably not, but the pain was so excruciating that I just wanted to pop something in my ears because I couldn't tolerate the pain. It's disqualifying. You ask most physicians, I would say, I don't say why you shouldn't fly with a cold. That's so stupid. They don't know what kind of decisions. And that's just a simple example. But any other medical problem is different because you're exposed to change in barometric pressure, you're exposed to vibration, to acceleration, to temperature differentials, to humidity. In the case of space, to microgravity, to radiation exposure. All of those things, most physicians don't know anything about them. So that's why it becomes a specialty. And there are very few of us around the world. That's another reason I love not my job, my hobby. I know most people around the world in aerospace medicine because we're very few, comparatively speaking, maybe a couple thousand. So it's good because if you do something good, everybody knows. If you do something bad, everybody knows too around the world. But it is a community where I go all over the world and they invite me to go. Why? Because we're just exchanging information and sharing experiences and knowledge and everything. Any other question? Any other question? Suggestion to me, did I go too high in the technology, in the technical complexity, or was it understandable? Okay? Okay. So after this presentation, how many of you would love to be pilots? Oh, at least we increased to 3 more. Okay, that's excellent. What about physicians? Or somebody in the medical field? Okay, that's good. And engineers, most of you. Yes, and artists, and there was only one artist. 1, 2, 3, 4. Excellent, we increased. Thank you.